My name is Ben Hsiao. I'm a professor in chemistry department at Stony Brook University. So I will also talk about water, but it's not the water that you swim or river. It's the water for drinking. Let me just start with a video. Okay. All right. So
The problem is simple enough. How do you take dirty water like this, turn it into clean water like this, at a cost very close to nothing? It's not easy. Globally, more than 750 million people don't have access to clean drinking water, and that number is surely headed up.
The human population growth is growing in such a speed, and all the resources are strained.
Chemist Ben Hsiao believes he can help. With support from the National Science Foundation, he and his team at Stony Brook University are hard at work on a new design in nanometer scale water filter that could soon make clean drinking water affordable to even the poorest of the poor.
In my mind, that human society is like a pyramid. So if we increase the cost of nutrition, that means we can only serve the technology to the top 30, 40% of the pyramid. If we can lower the cost of the filtration, we can lift the base of the pyramid.
Traditional water filters are made of polymer membrane with tiny pores to filter out bacteria and viruses. Hsiao's filters are made of fibers that are all tangled up, and the pores are the natural gaps between the strands.
Then an idea comes to us that if we make the fiber size very, very small, in the range of submicrons or nanometers, then we can really filter out very small molecules. So the stripping speed is 40 millimeters per minute.
The team's first success at making the new nanofilters uses a technique called electrospinning to produce nanofibers under an electrical field. Now they're looking to drive costs down even further by using biomass nanofibers extracted from trees, grasses, shrubs, even old paper.
So this means that we don't have to build new polymer plants in sub-Saharan Africa or South America, that we can teach people how to make filters with a locally accessible and sustainable biomass or waste, including newspapers or cardboard boxes.
Hsiao says it will still be a few years before the biomass filters are ready for widespread use in developing countries.
Pure drinking water is a basic human right. So the grand challenge is for me is to make it much cheaper, much more affordable. So people living at the bottom of the human pyramid can also afford it.
Using nanotechnology to bring clean water to the world. You might call this a trickle-down solution. Science Station, I'm Miles O'Brien.
I'm pretty inspired to see Edison's invention because I realized that I didn't know that he's actually a chemist, and in addition to other things. So I just looked at in the chemistry lab, he has a set of books. The books about agriculture products. He was using biomass. And biomass perhaps is probably most underutilized materials. We have so much from agricultural waste to agave leaves can be used for paper making. And I thought that I've been working on the recycling problems for most of my career. But then I think about it, recycling most of the time, I use materials that's more valuable, and after we use it, I recycle them so become less valuable. So it's called downcycling. So if we can use some truly bio waste that has zero value and we make it more valuable, that's upcycling. So I decided this is probably the way to solve this problem is probably should do the upcycling problems. So and again, this is we just published this result. We're using a very old chemistry which I learned from DuPont days. I worked for DuPont for 8 years, and DuPont used to make gunpowders. They actually use cotton fibers and use nitric acid, nitrate, to actually make nitrocellulose. So if you have a chance to go to Edison's bookshelf, you see there's a nitrocellulose book. So I realized that Edison's at one point is actually experimenting using nitro compounds to try to explore all his biomass. And so this is what we have done. And this method turned out to be much cheaper than any of the existing method to extract nanocellulose from any plant. Why is nanocellulose? Basically, it's when we eat a piece of lettuce, we try to digest all the parts that have nutrients in there, and part that cannot be digested, which is a fiber structure, and that's precisely the structure we like to have to build filters. And what happens if you use nitrogen-based chemistry to dissolve or digest your biomass? What happened to the effluent, the liquid? Well, you can actually neutralize it. It becomes fertilizer again. So this whole cycle can be done in a very inexpensive way. So this just to tell you this how valuable this nanocellulose can be. This is just a very simple experiment, piece of filter, just like your coffee filters. If I do some chemistry in there, I can make these filters into a absorbent. Those are the dye molecules, blue dyes. I can absorb almost all the positive charge crystal violet dye just by absorption. So I tell you a little bit of what I have done. I'm going to share with you what I really want to do. I'm not there yet, but this is a blueprint. I thought that if I can find the video again. I cannot find the video. Can I just go back to play another video? Just play here.
Hsiao, the chemistry professor at Stanford University. Water is my passion, and safe drinking water is my mission. And a filter like this can be a change-making solution for everyone. Similar to the ancient art of paper making, we have an easily taught, low-cost solution that can address the grand challenge of safe drinking water. By using biomass, the most abundant materials on Earth, we can create filters using nanocellulose, 50,000 times thinner than a human hair, to remove bacteria, viruses, and other contaminants. This project is truly a change maker. The current drinking water technologies involve synthetic materials, expensive to make, and not sustainable. We use biomass that is locally available and abundant. Our final products require low energy means like the sun, the wind, and gravity. I put together a team of experts around the world who share my vision. Within 5 years, our customized biomass solutions can be globally available as we teach and transfer localized technologies, offering opportunities to local communities. And you will put life-saving technologies, not just the filters, into the hands of those who need the most.
So this pretty much conclude my talk. I really convinced a group of cellulochemists, in specific the entire group from Sweden. They have the best wood science technology. And I try to convince them why work on wood. Wood if for example, if I'm a cow, I will not choose to eat a wood or tree. I would choose to eat grass, weed. So it's much easier to extract valuable nanocellulose by those materials that currently has very little use. So I hope this will work, and I'm actually experimenting to bring the technology to at least 2 countries in Africa, Kenya, and Botswana, and try that out, see if it will work. With that, thank you very much.